In this module, you will learn about loading data in GraphDB. Let's get started. Loading data may be accomplished by using GraphDB Workbench, which provides several ways, which we will see in the next slides. Parallel Load RDF tool, Preload tool, OntoRefine. The first way to load data from the workbench is by uploading local files. Click on Upload RDF Files. A new dialog window will appear. Select the files you want to upload and click Open. When the files are uploaded, either click on Select All Radio button or select one by one the corresponding radio buttons for each file. Then click on the Import button. A new dialog will appear where you can specify the base IRI and the target graphs. The settings for each import are saved so that you can use them in case you want to re-import a file. Also, you can expand the Advanced Settings submenu and select additional settings to be added. Adjust the advanced setting as you need. Click on the Import button and wait until the files are imported completely. You will be notified when they are ready with a green message. Another way to load data is to import it from a remote URL. First select Import, then RDF. Then from the User Data tab, click on Get RDF Data from a URL. Provide the URL for the data and click Import. To import RDF data from a text snippet, first select Import, then RDF. Then from the User Data tab, click on Import RDF Text Snippet. Paste or type the data directly in the text area and click Import. You can also insert triples into a graph with an insert query in the Sparkle editor. You can load data from files on the server where the workbench is located. This allows you to load arbitrary size files. The files are loaded from a specific directory on the server. By default, it is $user.home/graph db import /. You can change the directory to load files by using graphdb.workbench.import directory system property. Add the files directory on the server from which you will load the files. In our case, this is GraphDB import directory. Go to Import RDF server files. There you can view all the files which are on the specified directory on the server. Import the files as needed. Load RDF is a tool designed for offline loading of datasets. It cannot be used against a running server. The rationale for an offline tool is to achieve optimal performance for loading large amounts of RDF data by directly serializing them into GraphDB's internal indexes and producing a ready-to-use repository. It loads data in a new repository created from the workbench on the standard configuration turtle file, found in configs/templates, or uses an existing repository. In the latter case, the repository data is automatically overwritten. To run it, use the command line environment by typing load RDF command with its corresponding parameters. The RDF loader tool resides in the bin folder of the GraphDB distribution. To load data in a repository created from the workbench, simply run the following command in the command line. Load RDF, then the name of the repository, then serial or parallel mode, and the name of the RDF data file. To load data in a new repository initialized by a config file, enter in the command line, load RDF, then the name of the file for repo configuration, then serial or parallel mode, and the name of the RDF data file. Preload is a tool for converting RDF files into GraphDB indexes on a very low level. A common use case is the initial load of datasets larger than several billion RDF statements with no inference. Preload can perform only an initial load, which is transactional, support stop requests, resume and consistent output even after failure. To run it, use the command line environment by typing preload command with its corresponding parameters. The preload tool resides in the bin folder of the GraphDB distribution. The loading of a huge dataset is a long batch processing, and every run may take many hours. Preload supports resuming of the process if something goes wrong, insufficient disk space, out of memory, etc., and the loading is terminated abnormally. In this case, the data processing will restart from the intermediate restore point. instead of at the beginning. The data, collected for the restore points, is sufficient to initialize all internal components correctly and to continue the load normally at that moment, thus saving time. To load data in a repository created from the workbench, simply run the following command in the command line. Preload, then the name of the repository, then the serial or parallel mode, and the name of the RDF data file. To load data in a new repository initialized by a config file, enter in the command line, preload, then the name of the file for repo configuration, then serial or parallel mode, and the name of the RDF data file. OntoRefine allows the quick mapping of any structured data to a locally stored RDF schema in GraphDB. The following formats can be converted to RDF by using OntoRefine: TSV, CSV, StarSV, XLS, XLSX, JSON, XML, RDF as XML, and Google Sheet. OntoRefine is integrated into the GraphDB workbench, and the visual interface is optimized to guide you in choosing the right predicates and types, defining the data type to RDF mappings, and implementing complex transformation using OpenRefine's GREL language. OntoRefine enables you to upload your data files and create a new project, create an RDF model of the clean data, transform your data using spin functions, further modify your RDFized data in the GraphDB Sparkle endpoint. To load data into OntoRefine, start GraphDB in Workbench mode. Open a local host 7200 in a browser. Create a repository. Go to Import, Tabular, OntoRefine. Click Create Project, and then Get Data From. Choose how to upload the data. There are 3 main ways to do that. To upload data from your computer, click Create Project, and then on the Get Data From section, select this computer. Choose one or more files to upload. Then click Next button. To upload data from web addresses, URLs, enter one or more web addresses pointing to data to download. To upload data from the clipboard, paste the data into the text area. The next step is to adjust the table configurations and update the preview. With the first opening of the file, OntoRefine tries to recognize the encoding of the text file in all delimiters. Finally, click Create Project. To import an already existing OntoRefine project, number 1, go to Import Project. Number 2, select a file, .tar or .tar.gz. Number 3, then click on Import Project button. Once the project is created, to open it, go to Open Project. Click the one you want to work on. Optional, you can also delete your project if you want to. To RDFize tabular data, you need to map tabular data against an existing ontology. The steps for that are as follows. Upload an existing ontology into the repository. Go to Setup, then Autocomplete, and enable the Autocomplete index. Return to the OntoRefine project. Click on RDF Mapping, and then from the drop-down menu, select Edit RDF Mapping. You will be redirected to the mapping editor, which lets you to configure and preview the mapping model of your data, to save your mapping, to download a JSON model of your mapping, to upload a JSON model of a mapping, to convert the result of the mapping to RDF data that is downloaded as a .ttl file, generate a Sparkle query of your mapping and open it in a GraphDB Sparkle endpoint, create a new mapping. The headers of all columns in the tabular data that we imported are displayed as boxes that you can drag and drop into a mapping cell to configure them. Each row in the table represents an RDF triple constructed from the tabular data. You can close the mapping editor with the X button on the top right. The value mapping describes how a single tabular cell is converted to an RDF value. Each such mapping requires a value source, a value type, and may have an optional value transformation. Each value mapping has an associated value source, a column identified by name, a constant value, a record ID, or a row index. The value type defines the type of RDF value that will be produced by the value mapping. The possible types are IRI, literal, literal with a language, literal with a data type, any literal, blank node based on value, value B node, unique blank node, unique B node, resource, abstract. Each value mapping may have an optional transformation applied to the data received from the value source before the value is created. Each transformation has an associated language and expression. The expression is evaluated according to the rules of the language in the context of the value source. The languages are language prefix. The expression is a namespace prefix applied to the value received from the source if that value is not an absolute IRI already. Language GREL. The expression is a GREL expression. GREL is the Google Refine expression language that helps you define complex transformation. The mapping tree contains a set of prefixes that are used in the cell configuration. They are defined in the prefix area and can be of three types: default prefixes from commonly used RDF schemas, such as FOAF, GEO, RDF, RDFS, SKOS, XSD. You can select entities from these schemas without importing them into your repository.